Allard Martinet, Director of Development with Precision Makers, and he's going to present the application of autonomous equipment.
Thanks very much to the NIO team for inviting us. I would like to take you in a short presentation, 10 minutes, on where we are going. We have taken a little bit different approach than the former three speakers. We have chosen to robotize existing vehicles, and that is also one of the reasons why we are already commercially selling vehicles, and I will show you what we have done. We are part of a bigger group. We used to be a startup, but finally, if it all goes well, then a bigger group comes by and you are taken over. So we are part of a bigger group. For us, it's an advantage that we have 200 skilled employees who focus on manufacturing, on, for example, things like warehousing. The advantage is that us, in Precision Makers, 12 guys, can focus on research, development, sales, and service. So we do not need to bother on how to build, for example, a Dino or a TED, for example. Probably NIO will reach that phase also pretty soon, because finally, building something is something completely different than developing it. So we have the advantage, we can focus on R&D. For us as a company, we focus on all kinds of solutions linked to GPS and precision farming. We go wider than farming. We also are active, for example, in vegetable growing, in green environment. You can think about golf courses, football pitches, soccer pitches, all those kind of applications. And we have currently close to 100 robots running commercially and running every day. That's something different. I think in that way we are quite far ahead. We are based in Holland, but those robots are running worldwide with all kind of interesting challenges that come up when you start doing that. Just to give you a glimpse, on the top left you see several agricultural tractors which we have robotized. So these tractors can now do everything that you normally can do without a driver. On the right you see our application where we started first, mowing golf courses, mowing soccer pitches. Think about mowing in your home garden or home lawn. You need to do that pretty often, so mowing is one of the more easy applications that you can easily robotize. That is also why the bigger companies like Bosch, like Husqvarna, have started also in that application. On the left you see tractors in orchards, for example. In the middle, and I'll come to that, we have built our own robot. That is a different subject. I'll come to it in the last part of the presentation. And in the lower part you see that we also try to specialize in several applications that are not done by the bigger companies. You probably all know, like John Deere, like Trimble, like Topcon. They are specialized in GPS and precision farming solutions, but focus on a worldwide market. We also do that, but then in robotization. On the precision farming side, we focus on niches. So for example, yield monitoring on potato harvesters is not done at the moment commercially, so that is something we developed and actively sell for example, Grimme, AVR, and a few others. To go shortly back to our history, we were founded in 2008, but the first tests with a robot were done in 2001. It looked similar then to the one that NIO shown. So we have a little bit more history, but I'm quite sure that NIO will probably catch up or come really close. We started on a golf course. That was also a bottom-up approach. So we got really just a question from a golf course owner: can you not take away the issues that I have, and especially the cost of labor, the quality of labor, and the availability of labor? So that was the first thing. And then later on we started developing for agriculture, and finally we were taken over by a bigger group more or less 3 years ago, and then got the room to grow. For us important, all our technology is a sort of a kit. You can consider it similar to an auto steering system in agriculture. It's added to the vehicle, so you take the normal vehicle and you robotize it. It's an add-on kit. You can even take it off if you really want. What is good to know, one back, is that the machine more or less thinks there is an operator in the seat. So we control everything that is on the machine, for example, steering, the engine, the transmission, the power takeoff. All those kind of functions are controlled by the system, and the system plans what it needs to do. A key question today, I think, and it's also shown already a few times, are we talking about robotized vehicles or mobile robots? And I think that both approaches are possible. For the moment, we are focusing on robotizing an existing vehicle. It's a small step for most of the farmers, because they can still use the vehicle in the normal way when they want to do something quite complicated or something that is not easily to program. On the other hand, I think we will get specialized robots. This is our own green bot. dedicated or optimally suited to do, for example, one task. Think about most of the NIO robots, clearly in this kind of category, suited for a few tasks, specialized in that, doing that really well. But the general farmer still needs to adopt to the fact that he cannot have or use his normal tractor anymore, capable of doing 20, 30, 50 applications, but just buys one tool for one application. It's something new. We have to get used to that. So what are we doing? Now, this is an example, for example, of a 500 series Fendt seeding autonomous. So that's maybe not yet the March project, but we still seed with a big one without a driver. So this is in Denmark, for example, and we have roughly 50 of those tractors running commercially. So if you want your field to be sown without a robot, it is possible. On the other end, and I'll come to it, it is a little bit difficult. We have in general two technologies. One is called teach and playback, and you can really consider that something like a copying machine. It is useful for complicated tasks or tasks that you repeat exactly every time the same. And it's really as simple as two buttons. That's the only thing you have on the machine. You do teach, and then you record all the actions you do like you normally would do it. And then later on the next day, you come there again, you press play, and the system does it exactly the same. Useful for weed removal, useful for spraying in orchards, those kind of applications. It's exactly the same. On the other hand, we know that's not enough. So we have developed a system for dynamic path planning. And you can consider that if you have the field, you drive around it once, and then you say, this is my direction I want to work, and the system calculates automatically what you have to do. Short example, this is a golf course. So here you see that the system automatically calculates all the turns, even 3-point turns, the activation of the implement, all those kind of things, and does that then without a driver. This is how you see it in practice. So here the machine is active, doing everything without a driver, autonomous, and will finally also make the last round really nice. You have the advantage of a GPS system with all the kind of technology in it, but then driverless. What is the future? Because I think that's also key to a meeting like this. I think that repeating tasks will be automated pretty quickly. That's already what you also see in the NIO robots or in our robots. We have a lot of repeatable work in agriculture, things we do every week, every day, every month, or every year. Why not automate those? Make the analogy or the similarity in a factory, for example. A welding robot was also first used only to make every time the same operation. Think about milking a cow. That was also one of the things where the robots were introduced first. But there are a lot of applications also in the outside agriculture. Keep in mind, an operator has normally 3 tasks. One is steering or driving. The other one is acting, so controlling the implement. And the third thing is controlling. So what are you doing, and are you doing it well? That's a challenge. And especially, I wrote here the implement manufacturers. I think the implement manufacturers have a task to make their implements more clever. For example, if you have a plow behind your system, those implements are at this moment too simple or not sophisticated enough to give any feedback to a robot. So it could be that you thought you were seeding, but there was no seed in the tank, so yeah, you have an issue. That is a challenge. I think for the moment we will mainly sell add-ons, and later on you will have dedicated robots. But that is something that needs to start living in the mind of the user. Key of it, standardization of interfaces, for example, how to work together between the robot and the implement. Standardization of safety. Not really mentioned today, but safety is a key element. If you want to use something driverless, it needs to be safe. Luckily, in the car business, and especially in trucks, for example, platooning is advancing quite rapidly, and we can benefit from it in agriculture. But I would like to conclude, and that is also why this meeting today is quite good. The future is now. You've seen today already quite some presentations of interesting robots. Keep it in mind, robot technology is available. The question is just how to use it, but it's key. You can already act now. And that was what I wanted to outline in a short presentation.
Donc nous accueillons